It is part 2 of section 4.2, the general solution of linear systems. In the first part, we studied the concept of pivots, pivot positions, and pivot columns. Then we introduced the basic variables and free variables. As a review of the first part, here we'll begin with this example. For an augmented metric, is reduced echelon form is given as in this metric, then the associated system of equations can be written in this equation. Here x1 minus x3, so that here now this is related with x1, there's x2 and x3, and x1 minus 5x3 equals 1, and x2 plus x3 equals 4, right? Okay, and then the last one is 0 equals 0. Here, 1 and this one are leading ones, and they decide the pivot positions and pivot columns. So eventually, basic variables here, x1, x2 are basic variables. Okay, and so here we move everything except basic variable. We keep basic variables on the left hand side and everything else to the right side. Then here x1 is 1 plus 5x3, and from second one x2 is 4 minus x3. Now x3 is a free variable. Now rather than x3 is free, we can write in this way, x3 is x3. So it is always true. So we can add this line rather than saying x3 is free. The reason we are doing this way is that when you try to say a solution of the given system, then you have to find all values for all variables, x1, x2, x3. So we added one line here, extra line, x3 equals x3. Then from this one, now x1, x2, x3 is this constant vector, 1, 4, 0. And for x3, here the vector is 5, minus 1, and 1. So we reach at this solution. So for arbitrary choice of x3, the result will be a solution. So you can choose x3 freely. So that's the reason we call it a free variable. Okay, here the description in this equation is called a parametric description of the solution set. And the free variable x3 acts as a parameter. You can choose it arbitrarily. So it is like a parameter. The solution in the equation represents all the solutions of the system. These are all the solutions. So we call it the general solution of the system. So this is the general solution of the given system. Okay. Find the general solution of the system whose augmented metric is given in this way. So that means that we have to find all the solutions. And here, from this augmented metric, we have to reach to the reduced echelon form. Now this is a leading one, and leading one, and here leading one, but it's not in echelon form. once it is eliminated, then it'll become echelon form. But it's simple, just 8 times added, then that one will be eliminated, right? Okay, nothing else is changed. So it becomes the reduced echelon form. Now, from this reduced echelon form, the algebraic equations can be written in this way. Now here, this so that anyway, basic variables are x1, x2, 3, 4, 5, x5. These are basic variables, and of course here x3 and x4 are free variables. Anyway, we write down equations here. X1 minus 5 x3 equals 3. Now x1, okay, x2, the second row, x2 plus 4 x3 minus x4 equals 6, and third row is saying x5 equals 0. Okay, from this one, now we keep basic variables on the left hand side and everything else to the right side. Okay, so here from the first one, x1 equal 3 minus 5 x3. Now from second one, x2 equal 6 minus 4 x3 and plus x4. Now x3 is a free variable, and again x4 is a free variable, and last one x5, there's a basic variable which is 0. Now for these free variables, we write down x3 is x3, x4 is x4, right? Okay, for to make it clear, we try to fill out here the empty positions with 0. Okay, that is 0, that is 0, 0, 0, 0, right? Okay, so from this one, here x, which is x1 to x5, that is the same as a constant vector, 3, 6, 0, 0, 0, and along with free variable x3, the direction is now, okay, that must be plus, right? So it is a 5, now minus 4, and this is 1, and then 0, 0, and we have one more free variable plus x4, and then the direction is 0, 1, 0, 1, 0, right? So for the system here, you can choose x3 and x4 arbitrarily, and these are all the solutions, so that this is the general solution of the given system. Okay. Choose H and K such that the system given here has no solution, unique solution, and many solutions. Okay. Now for this one, so that we may start with this augmented metric 1, minus 3, and 1, and this is coefficient and this right hand side, 2, H and K. So we try to eliminate this one. So 1, minus 3, and 1, and twice subtraction makes 0, twice subtraction, that is H plus 6, and twice subtraction, that is K minus 2. Okay. So it is on echelon form. Now we consider case by case. A, no solution. No solution is happening when this is 0, this is non-zero. So h plus 6 equals 0, and k minus 2 is non-zero. Then 0 is non-zero, which is impossible. So there is no solution. And part B, unique solution. Now here, look at this one. If there's no free variable, then the solution will be unique. So that uniqueness of the solution is related to no free variable. Every variable is a basic variable, then the solution must be unique once it has a solution. Okay? So for that one, and unique solution means no free variable. So this must be a pivot position, which means that h plus 6 must not be 0. Okay? Now, how about many solutions? For this one, and you have to have at least one free variable, which means that h plus 6 must be 0. But if it is non-zero, then you don't have a solution. So simultaneously, here k minus 2 must be 0. So that these two are the condition for many solutions. Okay? Okay. Here, to find the general solution of the system of which the augmented matrix is given in this matrix. Okay, for this problem, let's try to use a computer program. We define the augmented matrix here, and then we use the function RREF for the augmented matrix. Then the answer result is given in this way. That is now leading 1, leading 1, leading 1. So x1, x2, x3 are basic variables, and x4 is a free variable. Okay. Here, from this one, now x1 equals now 7 and minus x4. 7 minus x4, and x2 from the second row, and that is minus 10, the constant, and left hand side is minus 3x4. On the right side, it becomes 3x4. Okay. Now third row, x3 equals 3 minus here x4. Now x4 is a free variable, so we can write down x4 is x4. Then from this one, x, this whole collection is x, and the constant vector is 7 and minus 10 and 3 and 0. Okay. And then here we have for x4, the free variable, the direction is minus 1, 3, minus 1, okay, minus 1, 3, minus 1, and 1. So this make all the solutions, so it is the general solution. Okay. Now we have true or false problem. The row reduction algorithm applies only to the augmented matrices for a linear system. Is true. The row reduction algorithm can be applied to any matrix. It doesn't have to be augmented matrix, so that it is false. Okay. If one row in an echelon form of an augmented matrix is given here, then the associated linear system is inconsistent, which means has no solution. Okay, but this row means that 1, 2, 3, 4, 5 here x 5 equals 0. This line means x5 is 0, but it doesn't mean that it has no solution. Once these numbers are changed, for example, 2 and 0 are changed, then 0 equals 2, which is impossible. That means there is no solution. But for the current row, it does mean it's not necessarily for the system to be inconsistent. It may have a solution depending on other row. Here the consistency may be decided. However, this row is not saying that it has no solution. Okay, so it is false. The pivot positions in a matrix depend on whether or not row interchanges are used in the row reduction process. Okay, this statement is also false. Here, and pivot positions are independent from the use of row interchanges. Even though you don't use any row interchange, you can decide the pivot positions. Once you reach at an echelon form, then you can decide the pivot positions in this reduction process, and you don't have to use row interchange if it's not necessary, right? So that the given statement is wrong. Reducing a matrix to an echelon form is called the fourth phase of the row reduction process. Is it true? Yeah, it is true. And here in the row reduction algorithm, okay, let's see here. And from A, now we apply and eliminate row operations and reach at an echelon form. These combinations of operation is the forward phase, and here after that an elimination of the other entries of on the column of leading ones is called a backward, because it's usually in backward order these non-zero entries are eliminated. So it is called the backward phase. Okay, so the last statement is true. Okay, that's the end of section. Thank you.